Okay, today we will start with relative motion. To the example 2, a man want to swim from point A to point B across a 12 meter wide river with a constant flow velocity of 0.6 meter per second. If a man can swim at 1.2 meter per second in still water, so this is the absolute velocity of the swimmer. The river with a constant flow, so this is also the absolute velocity of the river current. Determine the speed of the man as observed from the river bank and calculate the time needed to cross. Should he direct himself to point B at the start? Why? Okay. So maybe from your experience or of course from this diagram directly, we can see that if he swim direct from A to B, the river current will push him not to B but to the other side, which is far away from B due to this 0.6 meter per second. Okay. So to make sure that he can reach point B, he need to swim in a relative direction so that the absolute velocity of the current will push him to point B. So this is how we use the relative motion analysis. Okay, so how we analyze this motion? So this is how we can do that. If the man can swim at 1.2 meter in still water, then that 1.2 meter in running water is the relative motion of the man with respect to the water. From the equation, Vm equal to Vw plus Vm stroke W. The actual velocity of the swimmer M, it must be given by the velocity of water plus the relative velocity of man with respect to the water. We can draw this equation using the graphical method like this. Vw 0.6 meter down and Vm stroke W starting from the end of Vw point 2 to point B. So this is the actual path that the man need to swim, but due to the water, this is the relative path that he need to take to go from A to B. So we know that Vw is pointing down, so in the negative J, so negative 0.6 J, and the velocity of man with respect to water is 1.2. So in this case, theta is this angle. So Vm is separated into I and J by using this angle theta. Vm over W, cos theta I in the positive I and minus sin theta J in the negative J. While the actual velocity that the man need to take is Vm cos beta I minus Vm sin beta J. Cos beta is A over H, 12 over H, and we can find H by using theorem Pythagoras. Yeah? So in this case, cos beta I equal to 4 over 5. So if we look at the ratio, 12, 9, this is also equal to 4, 3, 5. So meaning 12 square plus 9 square will be, this is 25. So cos is adjacent over hypotenuse 12 over 25 or 4 over 5 V M in I component, and for the J component sine beta S O over H then over 25 which give us 3 over 5 in J axis. But the velocity is still unknown. We only know the angle. So we put back this into the equation. V main equal to 4 over 5 VIA minus 3 over 5 VMJ equal to VW minus 0.6J plus VM stroke W 1.2 cos theta I minus 1.2 sin theta J. And now we can equate the I and J components separately. So instead of only one equation, now we have two equations. One for the I component and the other for the J component. I on the left side should be similar to I on the right side. So 4 over 5 VMI equal to 1.2 cos theta. And for the J, again J on the left side must equal to the J on the right side. So negative 3 over 5 VM equal to minus 0.6 minus 1.2 sin theta, and two unknown with two equations can be solved. Finally, we get theta equal to 30.29 degree and Vm equal to 1.46 meter per second. And the time required, we're using a constant acceleration equation. We can find t equal to 10.3 seconds. So the man must swim at 13.29 degree angle with respect to x-axis. If he swim direct to point B, he will be moved away by the water. Now this is sample. Frame B moves to the right from rest position on the horizontal surface. On the horizontal surface at a constant acceleration of AB equal to 4 meter per second square. So constant acceleration. As shown in figure Q1, at the same instant, collar A is sliding down the shaft at a constant rate of 5 meter per second relative to frame B. Determine the velocity and acceleration of collar A after frame B has moved 2 meter. Evaluate the kinematics of the collar if the frame moves at a constant velocity VB on a curved surface having a constant radius of curvature. So this is the figure. This is a frame, frame B. Frame B moves on a flat surface at a constant acceleration 4 meter per second square, starting from VB equal to 0. VB or UB. So UB equal to 0. Okay, so AB moving to the right at 4 meter per second constant, starting from rest. And at the same time, the slider A inside the frame B is moving at a 5 meter per second constant. So to write the data, you should know what is this acceleration of A. So because A is in the moving frame B, so meaning the reference axis of A is moving with the frame B. So therefore, this is the relative velocity of A with respect to B. VA stroke B equal to 5 meter per second constant. So UB equal to 0, AB 4 meter per second square constant, VA stroke B equal to 5 meter per second also constant. And of course, from here you can see that the acceleration of A stroke B equal to 0. Okay. So the kinematic analysis is simple. VA equal to VB plus VA stroke B. So this is the velocity of VA. And AA equal to AB plus A stroke B. So AA equal to AB. After 2 meter, find the velocity of A and B. Also, after 2 meter, okay, and of course the acceleration given is AB constant and AA stroke B is also constant even it is 0. So we can use the constant acceleration formula. So we use V square equal to U square plus 2A delta S for B. UB is known 0, 2AB is known 5, and delta S is 2 meter. So VB square is 428 8 to 16, square root of 16. So VB equal to 4 after 2 meter. Of course, V A stroke B are still 5 meter per second because it is constant. The actual velocity of A given by VA equal to VB plus V A stroke B. So using this equation, we just put the value. VB is 4. VAB is still 5. And make sure this is in terms of a vector. This is 4 and this is 5. So this is the value of VA. 4 square plus 5 square is 6 point something. Okay. And for acceleration, AA equal to AB plus AA stroke B. So AB, 4 meter per second constant. So C4. AA stroke B is 0. So AA is 4 meter per second constant. Okay. So that is question number 2. And lastly, evaluate the kinematic of the color if the frame moves at constant velocity VB on a curved surface having a constant radius of curvature. Instead of on the straight track on the flat surface, now the frame B moving in a curvilinear motion with a constant velocity of VB. Is the velocity of A inside the frame B. So we go back to the equation. VA equal to VB plus V A stroke B. So VB constant, A stroke B 5. But now in the curve motion, okay, VB, VA stroke B. So this is VA. And for the acceleration, VB is constant. So the tangential acceleration is 0. So the only acceleration exists of B is in the normal condition. So AB normal equal to V square over rho. AA equal to ABN and AA stroke B adalah kosong. Okay, so that's the end of our lesson today.